So when you have an exponential growth is going to look like this, where your output's increasing over time. That's when K is greater than 0. But if you have an exponential decay, where the amount is getting smaller over time, then K is less than 0. Okay, so this is a growth model. This is a decay model. So an example of decay, we said, is radioactive substance because the substance is decaying over time. And they talk about what's called a half-life. A half-life is how long it takes a substance, a radioactive substance, to decay to half the amount, Okay, so say you have 1 gram of some radioactive material, plutonium or something, and just pretend that the half-life is 10 years. So 10 years go by and you have half a gram. So that would be 10 years. We're just pretending. And then another 10 years go by. 10 years. Now you only have a quarter of a gram. Oops, a quarter of a gram. And then another 10 years go by and you'd have 1/8 of a gram. Okay, and that's how it would work. Every 10 years you would have half the amount. That's what a half-life is. Okay, so they can use what's called carbon dating. And carbon dating uses the element carbon 14, which is an isotope. Okay, so it's an isotope of carbon. It's a radioactive isotope. And all life has some carbon 14 in it. Okay, you can read more about this in your textbook or in maybe a science book or something. But they have found that they can date things. They can figure out how old something is by measuring the amount of carbon 14 in like a bone or a fossil or something like that. Carbon dating is only good for up to about 80,000 years old. So older than that, you can't really use carbon dating. But our next example is going to show us an example of carbon dating. All right. So the Dead Sea Scrolls. Um, okay. It says use the fact that after 5,715 years, a given amount of carbon 14 will have decayed to half the original amount to find the exponential decay model for carbon 14. Okay, so this is the half-life. It's 5,715 years. So say you have 10 grams of something, some carbon 14, then after 5,715 years, you're only going to have 5 grams of it. So it's going to be cut in half. Okay. So they want us to come up with the model. So let's find our decay model. It's the same model as a growth model. And what we don't know is we don't know K, and that's what we want to figure out. Now, you might also be saying, yeah, but I don't know how much we're starting with. I don't know how many grams or what the amount is that I'm starting with, and I don't know how much I'm ending with either. You know what? It turns out that doesn't matter. Okay, so the amount that we have, you're right, we don't know what that is, but we know that after 5,715 years, we're going to only have half the amount. So whatever we start with, it doesn't matter how much, after that half-life, we're only going to have half the amount left. Well, now what I can do is I can divide both sides by a naught, and it cancels out here and it cancels out here as well. So I get 1/2, or 0.5, I'm going to put it as a decimal, equals e to the 5,715k. All right, so that looks a little cleaner. Hopefully it makes some sense to you. And now we're going to take the natural log of both sides. You might have suspected that. I'm going to put parentheses in there. Okay, and then what happens is that property 3, that the right-hand side is just going to equal 5,715K. And the left-hand side is the natural log of 0.5. And then we're going to divide by 5,715. And then those cancel, and then this will be, we're probably going to put this in our calculator and get a decimal approximation for K. So K is going to be approximately equal to, and then I think we go 3 decimal places, but I'll double check for you on that. Okay, so we are going to go what are called 3 significant, significant, this is why we abbreviate everything, significant digits. So there's going to be some zeros. By the way, we're expecting K to be negative because this is a decay problem. So if you put this in the calculator, you're going to get negative 0 point, and then there's going to be some zeros. I think there are 3 zeros. So let me put it in my calculator. You put it in your calculator and let's see what we get. So I'm looking at my calculator and yeah, it's negative 0.000, and then I have 1, 2, 1. Those will be my 3 significant digits. Okay, so that's what I'm going to use for K. And now I have a model. A equals A naught e to the negative 0.000121 t. And then we'll see what they're going to ask us. Okay, so part B. In 1947, earthenware jars containing what are known as the Dead Sea Scrolls were found by an Arab Bedouin herdsman. Anyway, analysis indicated that the scroll wrappings contained 76% of their original carbon-14. Estimate the age of the Dead Sea Scrolls. And I actually got to see the Dead Sea Scrolls. They were on display once when I was in Salt Lake City, and they're really small. I was really surprised. Anyway, so we're going to figure out how old the Dead Sea Scrolls are. So here we go to put it in the formula. So the amount we have is 76% of, so 0.76 of the original amount. Again, we're going to divide both sides by that original amount, but we'll put it in there for now so you can see it, so you don't wonder where it comes from. But you're dividing by the A naught, and those are out. Okay, so we have 0.76 equals e to the negative 0.000121 t. Natural log it. So the natural log of 0.76, now you could squeeze the natural log in here like we did before, and that's going to equal just negative 0.000121 t. And so you have to divide by negative 0.000121 on both sides. And then we're going to get the t to be, we'll put this in our calculator and see what we get. So stop the video. Okay, and I'm going to round off to the nearest year. So I'm going to say the time was about 2,268 years. Now, that's how old it was in 1947. So you'd have to figure out like how many years since 1947. So in 2020, let's see, what do you get? How many years have passed? Oh, well, it's 2022, right? Okay. So we have to do that if we want to figure out, accurately how old. So I need to add 75 years to that. So in 2022, let's see. Those Dead Sea Scrolls are 2,361 years old. Of course, next year could be the same textbook and it would be, another year older. But okay, so that is interesting.